lines given to you, but we started off with the lines already drawn. You just have to figure out where the shading was going to be. Okay, now you're going to have to draw the boundary line. So if you want to use two different color pencils you can. I'm going to shade with two different color highlighters. Okay, and then we're going to check the solution in each inequality. We're going to use a ruler to draw the straight line. So this first one is easy because it's already in slope-intercept form. Y equals mx plus b. If it's in that form, we can graph it just by looking at it. What we have to graph is we have to graph the y-intercept first. So that is the 4. So on the y-axis, we're going to go up and plot a point at 4. All right. Then we're going to use our slope next. The slope is the 2. So that means a rise over run of 2, which was 2 over 1. So I would count up 2 and then to the right 1. Or you can count down 2 and to the left 1. So based on this inequality, let me get my ruler, sorry. All right, so we need to make my ruler a little bit smaller so it doesn't take up, there we go. All right, so we need to line up the ruler, the edge of the ruler through the points. All right, so based on this inequality, the first explains how you know if you're going to use a dashed line or a solid line. That's the first question. So in this inequality here, is it dash or solid?
Oh, dash.
It is dash. Okay. How do I know dash is for less than or greater than? Solid is when it's less than or equal to, or greater than or equal to. So all I'm going to do is put little dashes in between the points. So that's our first equation. Our second equation, y is less than or equal to, oh, sorry, I got a shade. So because we have less or greater than, okay, this symbol is greater than, so you shade above. So this is my line. Above the line would be here to the left. All right. We're going to also graph the second one. Y is less than or equal to negative 2x plus 2. We need to start with the plus 2. So a point on the y-axis at 2. The slope here, sorry, this m is negative 2 over 1. So now we're counting down to the left 1. Or up to, down to the right 1, or up to the left 1. And we're going to line up our ruler. This would be a solid line. All right. But because our symbol here is less than means we shade below the line. So if I'm shading below the line, like such, the solution is where they overlap. So I'm going to put a capital S in this region because that's where the two overlap. So the question says, is there one solution for the system of inequality? Can there be one solution? No. No, there's not one. Why isn't there not one? Because it's saying just 1 point.
There's like
Multiple points.
Yeah, no. There are multiple points in the overlapping shaded region. There are multiple points in that overlapping shaded region. So it's not going to just be 1 point. There's multiple points. Okay, so I'm going to show you obviously how we can get a solution off the graph, but also how to find the answer algebraically. Okay, so what they want you to do here is just choose an order pair from the solution region, and then to the right we're going to test that point. So what we need to do is just choose a point in this overlapping.
-3,
-3, comma 1. So 1, 2, 3. All right, so I'm going to plot that point right here. -3, comma 1. There it is. It's in the overlapping. So the point we're going to choose, -3, comma 1. We're going to test the point for each equation over here. So to test it, our -3, sorry guys, this represents the x coordinate and the 1 represents the y coordinate. So I'm plugging it into the inequality for those places. So instead of writing the y, I'm putting the 1 there, greater than 2 parentheses, -3, and then +4. What I'm doing is checking to see is this true when I plug in those points. So is basically 1 greater than, this would be a -6 + 4, which simplifies as 1 greater than -2. Is 1 greater than a -2? That is true. Positives are greater than negatives. Are we okay on there? So we have to do the same thing for the other inequality. We're plugging in the 1 for the y, the -3 for the x. So we would write 1 is less than or equal to -2 parentheses -3, then +2. I'm plugging it in first. All right, you finish this one and test it. Basically, compare them after you do the order of operation, okay? So 1 is going to be hopefully less than, is 1 less than 6 + 2? Yeah, because you should get 1 is less than or equal to 8. That is true. Because they're true for both, it is a solution. So how do we know if an order pair is a solution? You will plug it in. And check, oops, sorry. If it is true for both. It's true for both inequalities. Now, like I said, Friday the lines were already drawn, okay? And so you didn't have to worry about so much if it was in standard form. But now, because you're graphing, you're going to have to solve for y first. So this is not in standard form here. So you're going to have to change it by first subtracting the 6x. So show the work and the steps to that. So this is now, I'm just going to rewrite it down here, is 3y less than or equal to -6x + 9. You still have to solve it for y. So there's one more step. What would it be? Yeah, divide everything by 3. Okay, good. So once I do that, now I have my y isolated. It's less than or equal to -6 divided by 3 is going to give me a -2x. And 9 divided by 3 is just 3. So now I have the equation to graph. So we start at 3. the y-intercept on the y-axis, and our slope is a -2, so we count down to the right one. Or you can count up to the left one. Let me get my ruler. All right, so when I'm checking, guys, especially when you do your scavenger hunt, because you're going to have to compare points, you're going to have to make sure you can graph the equation, or first at least write the equation. You can get it in y equals, and I know some of you are waiting for me to do it, but you really at this point should be able to do this. And this is what type of boundary line? Is it dash or solid? All right, so we got a solid line going through the points. Because our inequality here says less than, we're shading below the line. Okay. Now, anytime we have y equals a number, or y is greater than or equal to a number, that is a horizontal line. If it's x and a number, it's vertical. Yes, you do have to remember those special cases. So we go to this -y on the y-axis, 2, 3, right there, and this is going to be horizontal. So it's a dashed line. So I'm just going to go ahead and put my dash horizontal lines here. And because this says the symbol here is greater than, that's above. So we're shading above the horizontal line. And the solution is where they overlap. So that is here on the left little triangular piece. Okay, so this question says, a student states that any point on a boundary line is a solution. Meaning, any point on this line here would be a solution. What about here? No. It's not a solution on which line? Dash line. Okay, so this, hopefully we would say we disagree. Okay. Points on dash line are not a solution. So if we hit a point on the dash line, we cannot use that as a solution. All right, then they want you to do what we did. Let me move my ruler, sorry. Choose an ordered pair from the solution region. Test in each inequality. All right, so we're going to choose 1, 1. That is right here. It is in the solution set. 1, 1. So we're going to test them, plugging in 6 parentheses 1 plus 3 parentheses 1. Is that less than or equal to 9? Yes, this is true.
It's 6.
Yeah. Because this would. Oh yeah, it should be -1, 1. So it's negative. All right, so -6 plus 3 is a -3, which is less than 9. So this is true. All right, so all we have to do is plug in the y. If I plug in 1, is that greater than -3? Is a positive number greater than a negative number? Yes, that is true as well. Okay, so you have to plug it in and show. All right, so flip it over. So we're going to go from 2 lines to 3 lines. All right. Now, the first one is just 2, which I think you can do this one because it's already in slope-intercept form. So I'm not going to do 3. I'm going to talk about number 4. This is where we have 3 lines. So look at number 4 with me, please. All right, we're going to graph each inequality. So this first one is already in slope-intercept form, makes it easier. So we start at 3 on the y-intercept. What is the slope in the inequality? 1, so we're just going up 1 to the right 1. Our slope is 1 or down 1 to the left 1. Okay? All right, so we're just going to take the ruler. Let me get my ruler, which is up here. And we're going to put a solid line. Oops. All right, solid line through the points. I'm going to do that. And then this inequality is less than, so we're shading below the line. Our overlapping for 3 lines could form a shape. So that's what we're going to practice this one. Okay. Now, for this next inequality, this is a vertical, oops, I meant to do that right. This is a vertical line. So we have to go to 4 on the x-axis. There it is right there. And we're doing a vertical line through that point. Okay. Are you with me on the second one? All right, so this inequality, I'm going to do it in blue, is less than. So which way do we shade if it's the line vertical? Yeah, horizontal. Wait, no. Where do we shade?
Oh, where?
Yeah. For less than.
Above. To the left. To the left.
Thank you. To the left. Okay. All right, now I'm going to do this line in green. Y is greater than -1. So on the y-axis, I go to a -1. Is greater than, so it's a dashed line here, a dashed horizontal line.
Oh, yeah. That is too many lines.
And we're shading above. So we want the overlapping of the 3. So if I shade above and overlap, it's going to end up being right here, where they all 3 overlap. I just kind of made it darker. Okay. So it says describe the shape of the solution region. So what do we call a 90-degree triangle?
Right.
It is a right triangle. You can just put, if you want to abbreviate, right, and then triangle. Okay. So the solution region is in the right triangle. All right. So now what they want us to do, let me probably get rid of this ruler, is it says, what are the vertices of the solution region? Are they solutions? So the vertices, they mean the corners of the triangle. So like there's a vertex here, here, and here. Okay. So this, I'm starting with this point here. I'm just gonna label them A, B, and C, so we can kind of see where I'm getting the points from. So we have point A is at what, a -4, -1. My point B is at 4, -1. Is that right? Yeah. And my point C is at 4, 7. Okay. Says, are these points solutions?
Yeah.
Only one point is a solution. Yeah, only C. Only C. Why is only C a solution? It's on a solid line. Yeah. The other ones are dealing with the dashed line. Okay. So are these solutions? Only C. only 4, 7. I'm going to just abbreviate because on the solid line. I spelled that wrong. Solid line. Oops, what did I do? Undo that. What did I do?
What?
Sorry. There it goes. Alright, so how is a system of inequalities like a system of equations? How are these alike?
They both have numbers.
They both have numbers. You're right, but if it's an equation, do you have to shade?
No.
No.
But you still have points.
You still have points. You still have lines, okay? So the way these are the same is that you're still going to have intersecting lines. But equations do not shade.
Oh, the dash and solid lines are also.
Yeah, dash and solid, yes, are with inequalities. So how they different? We got basically dash lines versus solid lines. And there is shading. Now, my question to you, what if the lines never touch? There's no solution. It's parallel, right? So same thing. What if your shading never overlaps? There's no solution, okay? So if you have like parallel lines or no overlapping, it's a no solution. Yes? Uh-huh. All right, so you're finishing number 3, and then you put this in the tray. And then I'm gonna give you, I'm gonna while you're working on this, I'm gonna give you the scavenger hunt. And then kind of explain it. Yes. On this page? The bottom? Okay. Alright, let me explain how this works, because you're not gonna like go in order. Alright. Your answer leads you to the next problem. And your answer is in the gray rectangular boxes, the shading. Alright, guys. So we're going to start here, and what they want us is to come up with the inequality for each line. So I'm going to do the solid line first. To do this, I need the y-intercept, which is right here. That is a 3. And then I need the slope. I'm going to count rise over run. I'm counting up to over 1. All right, so this is going to be y, because it's shaded above, greater than or equal to 2x plus 3. That's what we're coming up with. We try to come up with the inequality. Inequality 2 for me is going to be the dash line. Again, I need to find the y-intercept. That happens here at a -6. And then I need to do my slope. This is counting down 1, 1, 2, 3, 4, to the right 5. Wait, 1, 2, 3, no, to the right 4, sorry. So down 1, 1, 2, 3, 4, 4. So y is shaded below, so it'd be less than a -1/4 x minus 6. All right, so we're trying to find these two in the gray box. Okay, I started here. I'm trying to find these two inequalities. We're looking for this one and this one. That's what we're looking for in the gray box, in the I found. Anyone find it yet? All right, it's the bottom here. Okay, all right, so we found it right here. So this is now our number 2. We did 1, now this is 2. Are y'all with me so far?
Yes.
Okay, so All right, so we're gonna do the solid. I'm gonna do solid lines if there's two solid. So like I'm gonna do this line first. In order to do that line, I need the y-intercept, which is at 0, and I need my rise over run. I would count up 1, 2, 3, and then to the right 1. So the m is like 3 over 1, and my b is 0. It's solid, right? Where is this shaded to this line?
It's the left.
It's to the left. So would it be greater than or less than? So y is greater than or equal to just 3x. The other line they give you, I don't know if y'all see this dash line here. So that's what type of line? So what's the equation? It's horizontal, so what am I gonna write? Where's the shaded?
Is it greater? No, that's less. It's greater than. Right?
Yes.
Greater.
Greater than.
I know that. Pretty sure you did. Why didn't you say? Why don't you hate it? Why don't you say? I bet you my pal. Why do you hate it? I think 2. No.
Is it 2? Hold on, let me erase this. Oh yeah, it is 2.
What was that?
Oh.
Okay. So this solution is here. It's. Do y'all see where I got the 2?
Yes.
All right, it's on the y-axis. All right, so we're trying to find where these two. Anyone find? It's probably on the back. We're looking for these two equations. Look in the I found. Did anybody find? At the bottom? No, that's not right. No, because we don't have an x equals. We don't have this. That's not in our equation. They're both y's. It's, yeah, sorry. Guys, I think these were both y's. Yeah, they are. This one and this one. Alright. Okay. Alright, guys, try to write the equation. Guys, try the solid line. Yeah, you'll have time tomorrow to finish.
Oh, I hate this whole.
Try to find the equation.
What intercept is 4. So is listed.
Are you okay? I don't know if you're doing this one. I don't know.
So I'm not simple. Are you looking for like the above and?
Yeah, I'm looking above and below. So if it's above, it's greater than. If it's below, it's less than. It'll be due tomorrow.
Oh.
All right, this will be due tomorrow.